In the first half of chapter 6, we were discussing decimals. All of chapter 6 is about decimals. But the first half was laying the foundation for decimals, understanding some of the terminology, and then we did the operations with decimals. In this section 6.3, we are going to be looking at a couple different applications of decimals, specifically percents and then scientific notations. Let's go ahead and get started by looking at our terminology and just an overview of what this section will look like. It's a bit of a shorter section, percent calculations with the percentages. We'll talk about mental calculations and approximations, and then scientific notation. So we'll start with just the word percent. The word percent, if we write it, P-E-R-C-E-N-T, and you just stare at it for a moment, you start to notice that it can really be broken up into two parts, per and cent. And what does that mean? It comes from the Latin word per centum, which literally means out of 100. Out of 100. If you think about it, you can find lots of words that have cent in them, particularly as a prefix, century, centipede, centimeter. And what do they all have in common? They're all talking about 100. Even our coin, 1 penny is 1 cent. It's 1/100th of a dollar. And so per means out of, and so percent means out of 100. So basically, whenever you see the sign that we use for percent, which is this, there's our percent symbol, it almost even looks like a rearrangement of the number 100 and a fraction sort of all combined together. The word percent means out of 100. So if we see 15%, it literally means 15 out of 100. And we have other ways to write that. We can think about it as 15 out of 100, like that, because we've seen fractions, the idea of a fraction used to represent 15 out of 100. And even if we translate it there to 15 hundredths, then it can be written in this form, which resonates with us from the first part of this particular unit. We can also look at percentages greater than 100. Sometimes this is a little less intuitive, but 125% is more than 100%. And if we know that percent means out of 100, then this means 125 out of 100, again, which may seem counterintuitive, but we can have fractions where the numerator is larger than the denominator, 125 over 100. And written as a decimal, that 5 would be in the hundredths place. And so both of these are completely acceptable. There are times when you can have percentages greater than 100. I think the easiest way to look at that is when something changes over time. And we'll see some of these applications later. But if something doubles, say we're talking about the price of a good, and the price went from $10 to $20, we say that it went up by 100%. It went up by itself. And so if something goes up by itself, it doubles in price, and so it went up by 100%. But it could also go up by more than that. And so it can go up by more than itself. If something went from $10 to $25, it actually went up by 150%. We'll get into all that later, but as a foundation, I think this is where we will start. Now, one of the ways we can model percentages are with 10 by 10 grids. And we've seen those in our conversations around decimals and also fractions. Think about our fraction squares where we have 100. And so I have a couple links for you in Blackboard, and this is one of them. I suggest you go play around with them and play around with them until they make sense and you can make predictions. What you're going to see here is a red dot on this percentage bar. So this is a percentage bar with dashes at each individual whole number percent. 0 on the left, 100 on the right. You'll notice currently it is at 23 percent. Below that is a decimal line from 0 to the number 1. We think of 100% as one whole thing, the whole thing. So the number 1 represents a whole, so it also represents 100% of something. Here, we're now envisioning this whole square as representing the number 1, right? There's one entire square, and we can see it broken up into 100 individual pieces. Those 100 individual pieces are also represented by each of these tick marks along this number line. If we want to drag this, we can click and hold and drag, and we will see that the decimal below moves, and our 100 square fills in at the same time. When we fill it all the way in, it's at 100%, and if we take it all away, it's at 0%. So this is just a nice representation, that visual representation of modeling or illustrating a percentage. Another one that I have in Blackboard is similar, but it takes it one step further as well. And it also changes the way in which you can manipulate the information. What you'll see in the middle is the percentage that we are representing. Along the bottom is that same decimal number line. We also see the fraction version over here represented in this pie chart. So we can see that it represents that fraction. And the thing you get to manipulate is actually the 10 by 10 grid. So if you click and hold and drag this, you can go all the way up to the top. And we drag across the left. Notice that this is changing by tenths along the bottom. 2 tenths, 3 tenths, 4 tenths, because I'm filling in an entire column. But if I drag it down, you can see it's now changing by hundredths. Every time I remove a square from my 10 by 10 grid, this is decreasing by 1. And then now watch the percentage grid as I go up. 32, 33, 34. The fraction increases as well, 35, 36, right? So we can see how all of these things are connected. The decimal, the fraction, the percentage representation of those numbers. We can also visualize what a percentage greater than 100 would look like. As you can see here, this is what 125% would look like if you had to model it using those previous examples. 125% means 125 out of 100, which we demonstrated earlier, or you can think about it as 125 hundredths, and each 100th is one of these little squares. So this notation is basically saying you need 125 of those fellas. That is 1/100th, and we need 125. The only way to do that is to fill in an entire 10 by 10 grid plus 25 more. And so you can see that represented in the visual, the percentage, the fraction, and then also the decimal. 1 and, remember how we say that? 1 and 25 hundredths. Good. Now, one of the things that can be a little challenging is when we have decimals or fractions within our percentages. Sometimes that can be a little challenging to see what that looks like. And so I'm going to start with this. So what we see on our left is the decimal 0.2, and it's represented by these 2 tenths bars here. We have a tenth and we have a tenth. So this together is representative of 2 tenths, either as a fraction or as a decimal, as you can see down here. What would that be as a percentage? Well, if you think about it as having 10 invisible lines going this way, these first ones are going to start neat, and then I'll make them less neat, but I should count 6, 7, 8. Right. So there are 20 hundredths now, if we look at it in terms of hundredths, 20 hundredths. So this is representative of 20%, 20 out of 100. Next door, we have the decimal 0.19, or how do we say it? 19 hundredths. We can see a full column here and then 9 tenths of a column here. So this is 19%. But what I really cared about for this conversation was this grid over here on the right. Take a moment and see if you could determine what the percentage would be here and make the connections between that and what these grids represent as well. If we start our focus by looking at these squares right here, we know that each one of those squares, like we saw over here and up above, each one of those is 1/100th, 1/100th, or 0.01 written like that. And so as you look through this, you might count those and say, well, we have 10 tenths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We've got 19 of them here. So we have 19 tenths, but then we also have this. If you can see that this is shaded in right there, that's another half of one of those squares. So, we have 19 tenths plus another half of a tenth. I gave you a grid that was not just cut up into hundredths, but it's smaller thousandths. And we can see that represented here, 195 thousandths, 195 thousandths. But when we are dealing with percentages, we're trying to represent it out of 100. That's what percentage means. So we can view it or think about it as out of 1,000, but we have to state it as its percentage as out of 100. So can you figure out what that would look like? Well, we already kind of did. We started this conversation by saying that there's 10 hundredths here, and then there's another 9 hundredths here, and then there's another half of a hundredths right there, right? So we have 10 hundredths, 9 hundredths, and then another half of a hundredths. So if we then just combine these, add these all into one number, 10 plus 9 is 19. Wouldn't that be 19.5%? 19.5 of these hundredth squares are shaded. And you can see it through this visualization. Often we would state that as 19.5%. Now we're going to learn in a little bit how to do some of these conversions without the drawings, of course, but I think the modeling is so crucial for, again, our understanding of what's really happening with these. Here's another example of that. So this diagram here, this visual, maybe the best thing to do is pause the video and just make a sense of it yourself first. It can be represented a few different ways. Through the model, we see that we have 3, I'll count them, I'll write them, 1, 2, 3 of our hundredths. So we can see that represented right here in our percentage, 3%, 1, 2, 3. But then we have this little section here. And this is 3/4 or 0.75 of one of those hundredths. So it's 3.75%. If we had been able to divide this up into the thousandths grid, like we did here, we would have seen that this is 375 of those thousandths, okay? Or actually, that's missing a decimal point in there. I was going to say, in my head, I was like, that isn't right. I'll fix that on the slide. That should be a 37.5 right there. Maybe it just didn't come over when I copied. 37.5 thousandths, okay? And then as just a straight decimal, 375 thousandths. So what I like to do now is I'm going to give you a percentage number. And your first job is to first think about what this would look like as a fraction. So what would this look like as a fraction? And then what might that look like as a decimal number? And we'll do one together first. So 42% as a fraction means 42 out of 100. So we could write it as 42 out of 100. If we then consider how that is stated as a decimal and read as in words 42 hundredths, it would be written like this. So 42% means 42 out of 100 or 42 hundredths. So this one is a little more challenging. Let's do 6.8. So I will also work this one with you. So if we start this by writing it as 6.8 out of 100, because that's literally what a percent means, out of 100, we know that doesn't look quite right because normally we don't state a percentage or a decimal in a fraction. So another way we could also do this is by writing it as 68 out of 1,000. How do we do that? By manipulating the fractions using the tools we already know how to do. Moving those decimals over one spot. It essentially is like multiplying your numerator and denominator by 10. And so we can write it as 68 thousandths. It's kind of the same thing that I did right here. Remember when I had this little error up here? 3.75 hundredths, if we move the decimal point one spot to the right in both the numerator and denominator, that's how we are able to get that. So then how do we state this as its decimal form? We're writing 68 thousandths. 68, and the 8 needs to go in the thousandths place. So that requires a decimal point in front of that 0, 0.068. So the next one I'd like you to try is this. 21 3/4%. See if you can figure out what that would look like as its fraction form, just one complete fraction, and then as a decimal number as well. There are a few different ways you could do this appropriately. We know because we are working with percentages that it's going to be it's 21 3/4 is between 21 and 22%, right? 21 and 22%. So it's going to be 21 100ths or 22 100ths. It's going to be somewhere between those two fractions. Okay, so that's like a starting point of what we have to think about. One thing you could do, and some of you might have done, is thought about your 3/4 in its decimal form, which is okay. Maybe some of you just, again, literally took 21 3/4 and wrote it over 100 because that's what percent means. That's okay, but again, we've got a fraction and a fraction, and normally that's not a standard way we would write that. So we could change that 3/4 to 0.75, 21.75 out of 100. Again, that is a fraction, but having decimals in fractions doesn't always feel right. So often we try to make them whole numbers. In this case, we'd slide that decimal 2 spots over, and we could do the same thing here. Slide that decimal 2 spots over, giving us 2,175 10,000ths. So this is equivalent to this percentage, and even both of those fractions. If we wanted to write this in its decimal form, we would have our 2175, and we just need to make sure that's in the 10,000ths place. And this would be the tenths, hundredths, thousandths, 10,000ths place. So 0.2175. So there's a little lesson, a little right conversation about how we might take a percentage and write it in its fraction form and also write it in its decimal form. Now, I took the long way on all of those. There's always some rules that we can follow with these. It's, of course, more important that we know the why and can kind of work the process, or at least understand the process. But anytime we want to take a percent and change it to a fraction, we essentially just drop the percent sign and put over 100. That's all we do. Again, you can simplify things, but that is the process. If you're going to go the other way, if you're going to go from a decimal number to a percent, so if we're going to start with a decimal number and we want to write it as a percentage, we're going to reverse the process, right? So we would take whatever decimal number that we have, say 0.09, and we would first write it as a fraction. We all know this is 9/100ths. So get it in that fraction form, and then you do the opposite of what we did over here. You get rid of the 100 and you add a percent sign. There you go. And there, that's it. You're done. So let's try a couple of these as well. So 0.07 is equal to 7/100ths. We remove the 100, we add the percent sign, and it's 7%. I would like you to try these on your own. 0.647, 3.25, and 0.008. Go ahead and attempt those on your own. So the first one, 0.647, is, if we thought about how that is written as a fraction, it's 647 thousandths, right? 647 thousandths. Now, I said you got to cross off the 100, right? Because percentage means out of 100. But this is actually out of 1,000. So what adjustment might we need to make first? How about we move this decimal back one spot and call it 64.7 hundredths. And then we remove the 100 and add the percent sign. 64.7%. Now I know what you're thinking. I know that you're thinking, hey, when I learned this, I was just told to take your decimal point and move the decimal 2 spots back to the right, 64.7%. And that works too. It does. But you know why we do that? You know the reasoning that you just move the decimal 2 spots back to the right. It's because you're essentially multiplying this number by 100, which is what happens when you move that decimal point from here to here, and you add that percent sign. This stuff here is all showing the why. This is the why behind just move the decimal point 2 spots to the right. So again, I'm always going to be challenging you to think about the why approach before the how. So 3.25, we would say that is 3 and 25 hundredths. But we could also say it's 325 hundredths. That also is appropriate. Add our percentage, cross off our over 100, and there we go. 325%. The last one, 0.008, would be 8 thousandths, but we don't want 1,000, we want it out of 100. So let's move that decimal one spot back to the left in both cases. 0.8 out of 100. Remove our out of 100, add our percent sign, and we're at 0.8%. And yes, it was just moved 2 spots back to the right with that decimal. So the last thing we'll do here is talk about changing a fraction into a decimal. So taking a fraction and writing it as its decimal equivalent. And so the way that we will do this is we will take our fraction and use the tools that we've already discussed here today. And it is taking that fraction and first putting it in its decimal form. So we'll use a decimal as the intermediary. So 1/5 as a decimal, again, this is where you can take multiple approaches to get there. You could divide to change it into a decimal. You could change 1/5 by multiplying both the top and bottom by 2 into 2/10, and then you know instantly that it's equal to 0.2. No matter what process you use, 1/5 is equal to 0.2. And then we need to get it into its percentage form. And that's what we just worked on. 2/10 can be written as 2/10. We want it out of 100, so we'll multiply the top and the bottom by 10, which is 20 out of 100. We know that 2/10 is the same as 20 hundredths. Remove our 100, add a percent sign, and we have 20%. I'm going to challenge you to know that one. 1/5 is equal to 20%. It's a very common fraction percentage, and so we're going to use that one a lot. It comes up a lot in real world scenarios. Sometimes you can have a fraction like this, which is very close to 1/5, but when you change it to a decimal, it actually is this. 0.16 repeating. We talked about repeating decimals in a previous section, a previous video. But if we just leave it like that for the time being, okay, we know that this is really a long string of sixes that goes on forever. What I'm going to do here is write it in its fraction form, or I'm sorry, take this and write it in its percentage form, where we put it as 16.6 repeating over 100, like we did here. And we're going to cross off the 100 and add the percent sign. You'll notice that I added a 6 and then the percent or the decimal with the 6 after it in the line rather than just a single 6. That's standard. You always want to write your line on the number after the decimal point. Okay, so 16.6%, 16.6% is correct, but because we've got that repeating number, that line over our repeating number, we tend to not give final statements written like that. You might be thinking, could we round that? You could, but one problem is that whenever you round something, it changes the number. So often this right here, 0.6 repeating, will be written in its fraction form because it's a very common fraction. I'm hoping you remember it. It's something we have talked about before. 0.6 repeating as a fraction is 2/3%. So 16 2/3%. The decimal 0.6 repeating equals 2/3. 0.3 repeating is equal to 1/3. Often we are going to replace those repeatings, 3 and 6, with the fractions 1/3 and 2/3. So this is a common way that this will often be stated. Just have you just try a couple more on your own. So we'll try these three fractions, 1/8 and 11/4, and then let's go with 3. I'm going to go with 3/16. 3/16. So take a moment to try each of those. So again, the way you'll start each of these is by changing them into a decimal number. And so the first one that we have there is 1/8. And as a decimal, 1/8 is equal to 0.125. And then we can write that as 125 thousandths, because that's how it is said. We move our decimal point one spot back to get 12.5 out of 100. Our whole goal is to always put it out of 100 because that's the meaning of percent. We cross off our percent, we add a percent sign, 12.5%. 1/8 is 12.5%. That's another one that I would just recommend that you know. It is such a common fraction that you should know it. 11/4. When we divide 11 by 4, we are going to get 2.75. 2.75. As a fraction over 100, it's going to go right to 275 over 100 because that's in the hundredths place. We can then cross off our 100, add our percent, and we say this is 275%. Remember earlier in this video, I talked about over 100%. 11 is more than double 4, okay? In fact, it's almost triple of 4. So that's why we get more than 100% here, 275. 3/16 when we divide it is 0.1875, which could be stated as 1,875 10,000ths as a fraction. We know we want it out of 100 though, so we're going to move our decimal 2 spots back in both cases. 18.75 over 100. Remove that 100, add a percent sign, and there we go. Now again, before we wrap up this video, what I will say is that, again, you've probably not approached it like that. And often when I teach things in new ways, learners will respond with, I'm just going to do it this way because it's easier. Right? I'm going to do it, my old way. This doesn't make sense to me. It's got to make sense to you. Or you've got to find a way to make some sense of it. It's all about connections between the fractions and the decimals and the percentages. To have a true deep conceptual understanding of it, you've got to find the ways to make those links. And the best way to do it is to go back up here, right? Consider these images, consider the pictures, always consider the meaning of percent out of 100. How does it relate to this? What will my picture look like? Every time you do a problem and do a conversion, you can think about it like that. It will take you a little bit longer to do, but then it's going to embed the concept. It's going to embed those visuals in your mind, and they'll just get easier and easier as you go. And then the process of just moving the decimal, let me go back down, just moving the decimal 2 spots to the right, if I go from here to here, there's my 12.5%. Then you know why that works. You understand why that works. And most importantly, you can explain why that works.